But, right, so for all it was hard to prove true, but easy to disprove. We just have to find one counterexample. There exists, existential statement, real easy to prove true. Just have to find that one is true. But based on the yin-yang nature of there existence for all, what do you think about the disproof?
You have to ensure that all cases are false.
Exactly. So how do we prove an existential statement is false? Well, to prove that this guy right here is false, right? We need to show it is false. We need to show P of X is false for all X and D, right? Yeah, because all this is saying that that's true for one. The same is saying it's true for one. So it's false, it must not be true for any. Meaning for any X and D, P of X is false. Oh, for any X and D, P of X is false. I.e., the way we can write that, for all X and D, P of X is false. Or another way we can write that is not P of X. So showing a statement is false is the same thing as showing for all X and D, not P of X is true. Does that make sense? You see in the yin yang now, the opposite of there exists is a for all statement about the negation. An opposite of for all is that there exists. Yeah. So for example, if we had, always. If instead we were looking at example, let's say there is an odd, or let's say there is an X and 2, 4, 6. That is odd. Which is basically already in the math terms. What we're saying here is there exists X and this right here such that X is odd. Does that make sense? And I'll call this O of X. So, my claim is that statement is false. It's not true that there exists an X in this domain such that that X is odd. And my proof goes like this. So again, to show that existential statement is not true, you have to show that it doesn't work for anything in your domain. So how do we prove it for all statement? How do we prove that for anything in the domain P of X is not true? What was that method?
The method of exhaustion.
Method of exhaustion, exactly. So to show an existential statement false is hard because we have to use method of exhaustion. So proof, note that 2 is not odd. Or I'll say 2 is even, not odd. 4 is even, not odd. And 6 is even. not odd. Thus, for all x in 2, 4, 6, O of x is false. Therefore, there exists x in 2, 4, 6 such that O of x as a statement is false. Any questions? Okay, then we are basically, what is that? We're basically done. This just leads us to one final key idea. I'll write them both down. The negation of a for all statement is an existential statement about the negation of the predicate. Is there exists x and d such that not p of x. If we're saying that for all x and d, p of x is true, if we're saying the opposite of that statement, we're saying there exists an x and d such that not p of x. Similar thing, if we're saying there exists an x and d such that p of x is true, the negation of that is that for all x and d, we must not have p of x. These are the key ideas. This is the yin-yang nature of for all. So for all, hard to prove, method of exhaustion. Easy to disprove, counterexamples. Find an example. There exists. Easy to prove, find an example. Hard to disprove, method of exhaustion. But this is the yin-yang nature. That's kind of interesting, right? Come on, a little bit, because we brought up this for all and this there exists quantifiers, because it just made sense. We're trying to make statements out of predicates. We're trying to specify how much of a domain we're claiming is true, right? And the two obvious things to do are just claim it's true for all of them, or claim it's true for at least one of them. Those are two pretty obvious things. But it turns out those are actually all we need to say negations of each other. It turns out they have this weird relationship. Well, I think it's cool. I don't need your guys' validation. Okay, it's not spot survey time yet. But yeah. Any questions on that? Because lecture's over. Okay, lecture's over. So we're going 5 minutes over. Have a great day, everybody. It's a Monday. I'll stop recording. Where's the there we go.